So let's take a look. So today we're doing the quiz on reviewing concepts, and then we're going to review chapters 7 through 9. Due today, you folks have Model Math 9.4 due tonight, and then that's it because you have your exam on Tuesday. Monday, I'll be doing a review next door in 2416 from 7:20 to 8:20. If you are in the Monday-Wednesday class, your review is tonight, Tuesday, at 6:20. So if you can't come on Monday and you want to review tonight, you can just stay after class. I'm going to review for an hour and 10 minutes. Most importantly, though, after the exam, those next 3 classes, so next Wednesday, Thursday, and the week after that, don't miss those 3 classes because we're going to cover chapters 10 and 11 in those 3 classes. So it's going to be kind of boom, boom, boom. So it's really critical that you're there those 3. If you want to miss a class after that, then that's not as critical. Right? But those 3, we're going to cover a lot of material in those 3 classes. So make sure that you're there for those ones. Exam 3 is for you folks, is on Tuesday, May 2nd at 4 o'clock. It's going to cover chapters 7, 8, and 9. Study guide, the answers to the study guide are in Canvas under study guides. There are also the regular study guides are there too, but the answers, if you need those, you all have hard copies. You're also going to need your magic formula sheet, half-page of written notes, your TI calculator, and you will need your T-table. I do have extra T-tables, so if you don't have one, I can give you one the day of the exam and just give it back to me so we can kind of technically use those. If you were not here to do the study guide fixes, which was a week or so ago, then you should check with someone else on that one. So quiz problem number 1. Interpret the level of significance in the context of the study. Conducting a study to see the mean income of newly graduated college students exceeds 42,143, using a significance level of alpha of 0.05. So we're interpreting this significance level. What is our significance level? What is it?
0.05.
Yeah, 0.05. So we're interpreting at 0.05. So what's my claim, first of all? What's the claim here?
Exceeding 42,000?
Yeah. Is it a mean or proportion?
Mean.
So my mean exceeds 42,143. Okay, everybody all right with that part?
Mm-hmm.
So then we're going to take a look at A. So A says, so what should we do, first of all, before we do that? Should we, in theory, should we reject H naught or should we not reject H naught? Oh, we don't know. I'm sorry. What's my H naught?
U equals that number?
U equals 42,143. Okay. All right, so then A is if the population mean of if it does exceed 42,143. So what this is saying is if U really is bigger than 42,143. If it's bigger than that, should I reject H naught or should I not reject H naught? My mean is bigger than really is bigger than 42,143. Should I reject H naught or should I not reject it?
Not reject.
What is my H naught?
Equals.
Equals. So should I reject that or should I accept that? Or should I not? Sorry, should I reject that or fail to reject that?
Reject.
Reject. Is that what I kind of follow in this?
Yeah.
Mm-hmm. If my mean really is bigger, I should reject H naught because H naught says I'm equal. So in other words, if H naught is false, is everybody kind of following me? Mm-hmm. Okay. So if my mean really is bigger, that means H naught's false. Okay. So then, if H naught, then in that case, then is there a 5% chance we would falsely conclude, so incorrectly conclude, so we'd make a mistake. So if H naught's false, then we would erroneously conclude that the mean does not exceed 42,000. Not exceeding means that we would erroneously not reject H naught. falsely conclude, so we would wrongly or incorrectly not reject H naught. Because if H naught's false, we should reject it. Is everyone follow what I'm saying? We're saying the mean is bigger, so I should reject H naught's incorrect, I should reject it. But incorrectly, I do not reject it. That's the first situation. It's saying there's a 5% chance.
Isn't that a type 1 error?
It's one of them. Yeah, it's 5% chance. I should rewrite this. 5% chance I wrongly do not reject H naught. Okay. And then there's B. B says there's a 5% chance that mu is greater than 42,143. So I don't know whether it's true or false, but there's a 5% chance that it's bigger. And then C, the last one, is if the mean does not exceed 42,143. So in other words, if mu is less than or equal to 42,143, which means that should we reject, is H naught true or is H naught false?
H naught is false.
False.
No, I should be, let me, this is, so if it does not exceed 42, my claim is that it exceeds.
Oh, we failed to reject H naught.
Yeah, so this would be, my claim is that it exceeds, U naught is that it's equal. So if it
Yeah.
doesn't exceed, that means it's equal.
Mhm.
So it means that H naught would be
Failed to
true.
yeah.
That's kind of a lot to wrap our heads around. Then there's a 5% chance we would wrongly reject H naught. So the question to you folks, and I'd like you to take, maybe a minute to check this over with your neighbors. Obviously A and B are errors. One's type A, one's type 2 error. And then B is, there's a 5% chance that I'm going to reject H naught. There's a 5% chance that I'm bigger, that I happen to be bigger. I truly am bigger. So with your neighbors, take a minute and discuss which one of these you think is, which one is the true definition of what the 5% should be. So, do you folks remember back the beginning of the semester when I had everybody flip 100 coins? And then anybody who had 59 heads or more, raise their hand. I think there was one person when we did it a couple times. That person would write a paper. So we watched that video about how 60% of all published papers are false. Because what you theorize is not true, right? H naught is really true. So you think that your proportion's different, but it really is the same. But you just happen to get lucky and get a weird result. So then you're like, yay, you write a paper, you get published. Someone tries to reproduce that, and they can't. Because it's not that the probability of heads is really different than 50%. It's just that you got a lucky result, kind of. Does that make sense? And that's going to happen alpha of the time. So it's when H naught's true, but you got a result where you rejected it and you wrote a paper. So think about it like this. That alpha is all about how often you're going to write a paper by mistake. Does that sort of make sense for folks? Yeah. So which one of these is H naught's true, but you write a paper by mistake? Or you convict. You convict. H naught's true, but you convict them by mistake. They're innocent, but you convict them by mistake, kind of in a way.
C.
C. Does that make sense for folks? All right, so H naught's true, but there's a 5% chance that incorrectly you're going to reject H naught. And again, that's just due to an unusual event. Which is why, if we're talking about trials and someone's life being on the line, we're not going to have an alpha of 5%. There should not be a 5% chance you get wrongly convicted. Right? You're really innocent. You know, I did not shoot that person, but there's a 5% chance I'm going to get convicted. That seems wrong, right? So in that case, if it was something like murder, your alpha would be really, really small, like 1 in 1,000, 0.0001, 0.001. There was this case with this nurse who people kept dying during her watch, like unusually high number of people kept dying during her watch, and not during other people's shifts. So they looked at all her shifts and compared her shifts to to shifts she wasn't working to see which ones had deaths on their shift, and they used an alpha of 1 out of 1,000. They used an alpha of 0.001, a really, really tiny alpha, because if you're going to convict somebody of murder, you need to have a really small alpha. You need to have a lot of evidence, a lot of proof, right? And they had enough proof. She really was killing people. Yeah.
Wait, so it's C?
So yes, this one's C. Jason's like, let's get back to the real thing. It's C, right?
Yeah, I was right there.
Yeah, you were right.
Okay.
It's like,
She told me.
you shouldn't doubt yourself.
Sorry. Austin, do you have a simple way of sharing that or remembering that?
Oh, this is just a theory, but like this is just a theory, but like if the question says like the claim says exceeds, then like why not just select the option where it says like does exceed at the end?
Yeah, I guess so, because you're saying, it's basically saying that the claim is true, well, or the H1's true. Yeah, there's a 5% chance that H1 would be true, or would be, yeah, that H1 would be supported if, would be supported. That is your alpha, you're right. So in other words, 5% chance that H1 would be supported, and you'd reject H0. So the one that says that at the end.
Hey, do you have to show that word for the
sorry?
exam on the left side? Or do we just circle it?
You just have to circle it.
Okay.
Yeah, so you have to write stuff. All the stuff I'm writing on the side, you do not need to write that. All I care about, all I'm going to grade is what you circle. Is everybody on board? Okay.
I'm gonna circle.
You could randomly guess too, but
I'm gonna circle all 3 of them. For partial credit.
yeah, no. If you circle all of them, you get 0 credit. If you circle 2, you get 0 credit also. You can only circle 1, unless I say circle 2.
But you still have a chance of
was that?
getting it. But you still have 1/3 of a chance of
Yep.
getting it correct.
Yep. Number 2. Rafa, read number 2.
You conduct the hypothesis test with alpha 0.05 and get a p-value of 0.0983. If you took a smaller sample and your sample proportion remained the same, your p-value would ...
Right. So here is my situation, and my alpha is 0.05. Well, actually, yep. And instead I get a p-value of 0.0983. So this is, I think I'll do one-sided because it's confusing. We have 2 sides probably, huh? So this is 0.05. So an alpha of 0.0983, would that be in the rejection region or the not rejection region? Anyone?
Not reject?
Yeah, if my p-value is 0.0983, am I going to reject or not reject?
Not reject.
Not reject. So it's going to be over here. Does everyone kind of follow that? So this space here is 0.0983. So I have some evidence, but not a lot. So I'm not rejecting H naught at this point. If I take a smaller sample, am I going to have more evidence or less evidence? Less evidence. So a smaller sample means less evidence. So what would that do to my p-value? Would it increase or decrease?
If you had less evidence?
Yep,
Increase.
increase. So everyone good? Nice. Nicely done, everybody. So those are the ways that you should sort of think about it. When you think about sample size, think in terms of less evidence, more error. Does that sort of, everyone kind of following? So I guess in general, I'd say sample sizes means less evidence, more error. So evidence will have to do with your hypothesis tests. Error will have to do with your confidence intervals. Right, I'll put more error. So this is for tests. This is for confidence intervals. What are two possible results when you fail to reject a null hypothesis? Pick two. So A or B, pick one of those. C or D, pick one of those. I'll give you folks 15 seconds with your neighbors. They can always come to consensus. So the first one, if we fail to reject the null hypothesis, do we have enough evidence or not enough evidence?
Not enough.
Not enough evidence. It's A. Also, maybe I'll draw a picture for this part. Right, so here is my rejection regions. Here's mu naught in the middle. If I fail to reject the null hypothesis, am I on the rejection region or the non-rejection region? Shaded area or the not shaded area? If I fail to reject the null hypothesis.
Non-shaded.
Non-shaded. Everybody okay with that part?
Yeah.
If I'm in the non-shaded region, I do not reject the null hypothesis. Does that mean that my difference from my sample to here, is that likely that it's due to random chance, or is this really different from there?
Random chance.
Random chance. Remember, anything in here, we attribute that to random chance. It could just be random chance, because it's going to vary a little bit. It's never going to be exactly there. If I get something way out here, that's when we say that's got to be due to a real difference. My mean really is different than the general mean. Okay, so this one's just due to random chance. C. All right, what does a small p-value mean? Pick two. Does it mean we have enough evidence, or do we not have? We do not have enough evidence, or we have enough evidence?
We have enough.
We have a small p-value. We have enough evidence. Everybody all right with that part? And then, is it likely that the difference between my value and the observed value? Again, we're looking at this situation here. Here's my value. Let's see, I rejected. So small p-value, am I in the shaded area or the non-shaded area? Shaded area, I'm over here. So here, is it likely that the difference between my sample and mu naught, remember mu naught or p naught's always in the center, is that due to random chance, or is that due to the fact that they really are different?
They're different.
They really are different. What does a confidence interval mean? Okay, I'm going to give you folks 60 seconds to discuss this one. All right, so what does a confidence interval mean? The first one, we're checking to see if we have enough evidence to support our claim. Those are all hypothesis test words. That is not a confidence interval. It's the probability that an individual falls in a certain range.
No.
Individual. Remember, confidence intervals are all about the whole population. So the population mean, the average, right, the mean, or the population proportion. So it's never about an individual. It's about the whole group. So not that one. It's an estimate of what values we think the true mean lies between.
Yes.
Yep. Because this one also, a guess of where we think the sample mean is. You never guess where the sample is. You always know where the sample is. Right? You never have to guess at the sample. So that would be wrong because you never guess the sample. Okay, great. Now,
Are there any questions like this in the exam?
yes, there will be 8 questions like this on the exam.
Oh, the circle one?
The circle ones, yeah. They're worth like 2 to 3 points each. So they're worth like less than a fourth of the test.
And there's like 10 like word problems or?
And then there's 8 word problems. There'll be yeah.
Study.
Yeah.
Is this easier than the last one?
Was that?
Is this easier than the last exam?
I think so. I think the way that I'm doing, well, see, it's a little bit trickier because
Is it longer than the last
it
one,
used
or-
to be 2 years ago that this one was about the same, or maybe a little bit about the same. And then last semester, when we started really focusing on doing things with the calculator, it got to be a lot easier than exams 1 and 2. But I was a little bit light on those questions that we just did a second ago. I just gave them like 3 of them for like 2 points each because I didn't really explore them like I had with you guys. I just showed it to them once. I was like, oh, let me just throw some at you. And then, so now that we spent several days, we spent like 5 different classes, working on some of these, then I don't know. I guess we'll find out. But I believe it's easier. You may disagree with me. So after we grade them all, then we'll find out. But I suspect that they are probably either about on the same par. Maybe. See, the thing about it is last exam was really easy, except for there's like always like 1 or 2 things that people stumble over. Like if you didn't get the central limit theorem problem, it just smacked you down, right? That's 7 points. So this will be the same thing. If you forget about the fact that you have 2 independent means, 2 means and you don't realize that they're dependent and you do an independent test on them and you lose 6 or 7 points on that, then that will kind of smack you down there, right? So that's the thing. There's little things that could trip people up and it's different for each test. Yeah.
We're gonna still have 2 hours, right? Not 1 hour?
Yep.
Okay.
2 hours. Yeah, for sure. Yeah. It goes back to being that one because it's it is longer. This one's definitely longer of an exam.
Oh, I need that 2 hours, not so long.
Though, I mean, think about it, it is and it isn't, because my other classes, they'd have to look up all the critical values, and the problems would take them like 10 to 15 minutes per problem, whereas you guys can whiz through the problems in like 5 minutes. So, 5 or 6 minutes. So the problems take you about half as long, I think,
Because of the calculus.
because of the calculator functions. You have to look up the critical value and have to find the test stat blank minus blank divided by the square root of this and calculate that. You can just put it in the calculator and it gives it to you. Yeah,
Is this a 1 full exam or is this a 2-part exam?
this is a 1 full exam. Yeah, it's 5 pages.
Wait, there's no fill in the blank, right? It's just a circle?
Circle.
No fill in the blank?
No, fill in blanks gets a little bit fuzzy, right? Then
Yeah.
I expect you to, unless I give you the words that I want, I have to either give you a word bank,
Z-score?
Right.
right? Or I have to, or like the Z-score, I make you memorize it, right? So if I don't like those otherwise. I feel like it's kind of, it gives people too much freedom to like, and that's just wrong. Too much freedom is confusing. All right. I will, however, have these problems where I say, show all steps. If it's a hypothesis test, you know how many steps there are in a hypothesis test. How many are there? 5. You know that. For confidence interval, I want to make sure that you realize I want 3 steps for the confidence interval, and these are the 3 steps. I want you to give me the best point estimate. I want you to give me the confidence interval. And I want you to give me the margin of error. If you do it by hand, if you find the confidence interval using your critical value and you compute it that way, and then you add or subtract that from the mean, then you could do step 3 and 2. You can swap those. You can do step 3 first and then step 2 last. It's fine, whichever way you do it. But you do need to have, when I say show all 3 steps, that is what I mean, and you need to know that. And these are the 3 steps. Let me give you a quick example. Here's a confidence interval picture. I want you folks to, so here's my, if I've kind of drawn it out, this is what it would be. Lower limit, yeah, X bar, upper limit. I want you folks to find the best point estimate and write it down. Write down what you think the best point estimate is for this conventional picture that I've drawn. And then, do you folks have it already?
Yeah.
Okay, what is it?
32.1.
Yeah, it's the number in the middle. That's that's the best point estimate, the number in the middle. Your p hat or your x bar. Okay, now I want you to give me the actual interval, blank, comma, blank, in parentheses. All right, so what's our confidence interval? What's the actual interval?
30.2 to 34.6.
Yep, that's our upper and lower limit. So 30.2. So 34.6. And then finally, find my error, E. What's my error, E? Anybody?
2.2.
Yep, 2.2.
Do you want us to specify saying like plus minus 2.2?
No, you don't have to. Because the error technically is just the positive one. So even though once I said plus minus on something, I'm just going to go with just the plus because that's the error. I wouldn't say, I'm going to guess your age between -3 and +3 years. You'd say within 3 years. Does that make sense? So yeah, so the error is really just the absolute value number. Yeah, thank you for asking that. It's a great point. And on your problem, I will give it to you as 2.2. I won't give it to you as plus minus 2.2. So even though it says that on one of your quiz thing or on one of your sample guides, I would give you the error of just the straight number, not the plus minus. So let's make sure that we'll get to that later on today. But I guess what I'm saying is it's going to come to you just as not the plus minus, but just as the straight up number. All right. And then remember proportion. The hardest part about this exam for folks is figuring out what kind of problem it is. Because if you do a proportion when it's a mean, or vice versa, or if you do a confidence interval when it's a hypothesis test, or vice versa, or you do a two-sample independent instead of a two-sample dependent, right away you lose 6 or 7 points on that problem, which is significant, right? So, and it's not hard to sort them out, just people need a little bit of practice to do it. So they get practice looking at the cues. So we're just going to spend a little bit of time determining if there are proportions or means. How do you know if it's a proportion? Well, how do you know if it's a mean?
That's a mean, average.
Yep, it'll say mean or average and standard deviation, or it could be a mean in disguise, which would be a list of numbers. Yep, so a list of numbers, expecting you to find the mean and standard deviation. If your data, whenever your data is numbers, that's a mean. If it's not a mean, then it's a proportion. That's the easiest way of telling it's a proportion. Good. You know, it could have those cues, the percentage or the, this many students out of that many students, but the key thing is it's not a mean. How to tell if it's a confidence interval? Confidence interval always, always, always says estimate or confidence interval. Always. It has to give you one of those two. If you look on your yellow sheet, what does it say on the left-hand side under the title? Right here. It says estimate, in parentheses, confidence interval. So confidence interval will always say that. A hypothesis test will not say that. That's the easiest way to know it's a hypothesis test because it won't have the words estimate or confidence interval in it. In addition, it may or may not, but it may possibly say things like test, claim, conclude, and have a question. So those are all possibilities. Sample, is it one sample or two samples? If you find the actual word sample, selected, or surveyed, and figure out how many groups were sampled, you should have a sample size for every sample you have. So if you only have one sample size, then it's usually one sample. So make sure you know. They could be the same sample size, right? You could have 50 men and 50 women's sports at a college. So that's a possibility, but you should have a sample size for both. All right, and again, you folks know these are the 5 steps you have to show. So I will say, show all steps, and you will know that that means these 5 for hypothesis tests. All right, so again, do not solve these, just identify the type of problem it is, whether it's a proportion or mean, whether it is a confidence interval or a hypothesis test. All right, go ahead and read.
Do not solve, just identify the type of problem.
Oh, just the researcher.
Yeah,
Okay.
a researcher claims that the average wind speed in a certain city is 8 miles per hour. A sample of 32 days has an average wind speed of 8.2 miles per hour and a standard deviation of 0.6 miles per hour. At alpha equals 0.05. Is there enough evidence to reject the claim?
Great. 30 seconds with your neighbors. What kind of problem is this?